Squeeze theorem. You have a function g, which is my bn. You want to prove the limit of gn. So you build a lower bound and upper bound. So I have a fx and I have a hx. And of course, I want both lower bound and upper bound converge to the same L. Then I can squeeze the gx to L. How do you prove this? You can say, I just do L hospital rule. Then this one is easy. Let's see how do you prove this without using L hospital rule. First, ex, because of 2.2.2.8, blue part is just this big chunk of thing. Now I have 1 cancel out. All these terms have x. I just divide by x, I get this guy, what is this, like ex, but no, because this is power 1 divided by 1, power 2 divided by 2 factorial, but this is power 1 divided by 4 factorial, so this is somehow looks like ex, but not actually ex. What is this? This is, I simplify my middle guy. So I have a g, I want to find f, and I want to find h. So what the heck is this? For all x between 1 and -1, and x is not 0, because you cannot put this guy 0, you have division by 0, okay? Then we have this, what the heck? This thing is actually this thing, right? So for example, this guy is x to the power 1, and then what? 2 is 1 plus 1 factorial, right? So exactly it's this thing. And then what's this? X to the power 4, 4 plus 1 factorial. So it's this thing. So basically what I'm saying here is that everybody here is smaller than something here. How do I know this inequality? How do I prove A smaller than B? I just prove A divided by B is smaller than 1. Of course, I need to make sure they are not 0. Then I'm now proving this thing over this thing. So this is what I have. And then this is equal. I simplify. So this 2n jump to the top. So I have here. This n plus 1 factorial go down. So I have here. So I have this part. And then this is xn, this is x2. So these two terms combine. I get this one. And now I have this. And then what? Any number j is always smaller than the absolute value of j, right? So I just suddenly add the absolute value here. So now I have this funny thing. Why am I doing this? Because x between -1 and 1. Whenever you see y between theta and negative theta, you need to know this means absolute value y is smaller than theta. They are the same sentence. If you cannot go from here to here, you need practice. Usually you can go from here to here, but you also need to go from here to here. So because I said x is between 1 and -1, so immediately I have this. This is the reason why I make an absolute value here. Because of this, then something smaller than 1, the power will be smaller than 1. So this whole thing, I can delete it. Then I have this. Okay, now I have this. The thing below is larger than the thing on top. This is an exercise in MacBook on mathematical induction. So this whole thing is smaller than 1. So let me give you a big picture. Do not focus too much on one particular sentence and then you get stuck and then you forgot where we are. What I'm saying is that I want to prove this limit go to 1 for x between 0 and -1 and 1. What is this step? This step is simplifying what I have right now. What is the simplification? Oh, I have a -1, I have an x, so first I do the expansion so that this underline becomes this long underline, and then I cancel out the 1 and divide by x, so I get this thing. So basically this is simplifying what I want to do. And then what? I want to find the upper bound, so I want to make things small, so I study how to make things small. A smaller than B is the same as I prove A divided by B smaller than 1, right? So all this thing I'm doing is basically proving that, yeah, this is true. Therefore, I have this conclusion. Why I'm starting to talk about this? Because this is exactly these guys. So everybody here will be smaller than this particular thing. So this thing is this thing. By this box, I apply it to all this. Then I have this inequality, which I have this big chunk of thing. These are all x squared, so I can take the x squared out. The denominator is 1, 2, 4, which is 2 by previous example. This add up to 2, so I have this thing. Limit x go to 1, 1. This is the picture. Blue is what I want to prove for limit go to 0. I'm finding two particular functions, a lower one and an upper one, that squeeze this guy at the limit. If these two functions squeeze my blue curve at this particular point, then of course this blue thing converges to this particular point. That's it. Let me give you a bigger picture. Sometimes when you want to prove limit in high school, you always work on this guy. Sometimes this is very difficult to do. Then what you do? Instead of spending effort to prove this guy, you spend effort on these two guys. They are equivalent. Because if these two guys you have this and then they both convert to L, then you have proved that this guy converts to L. So this is the trick or the strategy. Sometimes working on this is very difficult, but nobody forces you need to work on this, right? You can also work on this. The difficulty here is that working on this is very difficult. The difficulty here is that creating these two guys is difficult. And this actually is the key point why people are good at math and some people are not good at math. People that are not good at math is they only know one trick. People that are good at math, they know many tricks. This is one example of the many tricks. Who said you need to work on this forever? You can work on this too.